Right. Good morning or afternoon, as the case may be. This is going to be the last video before the test. And quickly, it's going to be about resistors and parallels. I'm cutting this chapter a little bit short because of time, so let's keep going. All right, equation. Yeah, I know it's misspelled. When we're talking about things in parallel, we're talking about, whoops, I need my pen, that the resistors are in parallel. So then get to where you're supposed to be. So the resistors are, you got one up here and you got one down here. Crappy drawing, I know. So they're not in series, because series is one after the other, but they're in parallel. And so the voltage drop from this point to this point is going to be constant between these two, but the current's going to be different. Because one's going to be, say, this is 10 ohms and this is 5 ohms. This is going to have twice as much current. This is going to be twice as much current as this, because this is going to be higher resistor. It means it's blocking more current. So you got more current going this way and less current going this way. This is what things in parallel do. You same voltage across, but the amount of energy being used is going to be different between the two resistors. And so we have the current total. It's going to be current go through A and then through B. And so V is equal to IR. V is constant. So we're looking at the resistance. It's not, when we look at parallel, it's going to be 1 over everything. Because remember, I is equal to voltage over R. Voltage is going to be constant, so we're just going to divide everything out. So current of 1 is equal to 1 over R1 plus 1 over R2 and so forth. And that means the total resistance is going to be Req. So here with these problem sets, do not go R1 plus R2 equals Req, because that's wrong. And when you add them, don't do this either, because that will be wrong. So the best thing to do is convert everything to a decimal and figure out and do the inverse of the decimal. So let's do a simple problem. We got calculate Req. So we have Req, and that's going to be 1 over that is equal to 1 over 12 plus 1 over 15 plus 1 over 20. This is what the equation looks like. So let me do it up here. 1 over Req is equal to 1 over 15 plus 1 over 12 and 20. So to do this, let's change each of these to a decimal. So 1 over Req. So 1 divided by 15 is 0.066 repeating, plus 1 over 12 is 0.083 repeating, and let's see, 1 over 20 is going to be 0.05. So we add all these together. That's going to equal 0.199, and let's assume that's going to be 0.200, because it's going to be 99 repeating. And take the inverse of that, and Req is equal to 5 ohms. So 1 over Req is equal to 0.2. So take the inverse of this, or take 1, divide by 0.2, you're going to get 5 ohms. Now the next question up here says, calculate the current going through each resistor. So each resistor drop is going to be 15 ohms. So the current, I1, is going to be voltage, what did I say? 15 volts divided by 15 ohms, excuse me. That's going to be 1 amp. I2, the current is going to be 15 divided by 12. That's going to be 1.25 volts, amps, excuse me. And I3 is equal to, what does it say, 15 divided by 20. That's going to be 0.75 volts, amps. And so the higher the resistance, the lower the current, which is what we got here. And the total current, I total, through this set of parallel resistors is going to be 3 amps. And this is how this works. So this is a way to get everything going through, and that matches. We go V total 15 over 5. That's going to give us 3 amps. So those 3 amps get divided into each of these 3 resistors like this. Okay, so let's figure out what the next question. We've got 3.3 resistor connected in parallel with another resistor across the 3-volt battery. We want to know the value of the unknown resistor. So we know that I1 is equal to the total volts over the resistor. So I1 is equal to 3 divided by 3.3, 0.90. Let's go 0.909. This is the amps. Now, there's many ways we're going to do this. And one way is we know that Req, if I total is going to be equal to is 1.41. And that's equal to I1 plus I2. So 1.41 equals 0.909 plus I2. Subtract the 2, and you're going to get 0.501 is equal to I2. So V is equal to IR. We're looking for R, so V divided by I is equal to R. And then volt is 3.0 divided by 0.501. And that gives me my resistor. And that's going to give us almost 6 ohms for the resistor. Another way to do it is go Req is equal to R1 plus 1 over R2, which is 1 over Req is equal to 1 over, and we know this is 3.3, plus 1 over X. We don't know what that is. Req, remember, is Req is equal to the volt total, which is 3, over the amps, which is 1.41. So 3 divided by 1.41, that's 2.127, actually 128. And so 1 over Req is going to give me the value of 0.47. So 1 over 0. So I should say 0.47 is equal to 1.3.3 plus 1 over X. One divided by 3.3 gives me, this is 0.303. So subtract the two, 0.47 minus 0.303, that's 0.167, is equal to 1 over x. Hope you see what I'm doing here. Then take the inverse reciprocal, and you're going to get 5.988, which x is going to be equal to basically 6 ohms. So we get the right answer no matter how you do this. If you have any questions, please give me an email. Thank you.